This video is going to be on sequences and their nth term rules. So looking at this first example, I have got a number sequence, okay, 7, 11, 15, 19 and 23. And what it's asking me to do is to write the nth term of this sequence. So the way I would go about doing this is, first off, I would find the common difference. Now, you probably have come across this as the rule, but what is happening to each number to get the next number? And hopefully you can see here that I'm adding 4 each time, adding 4. So hopefully you can remember that the nth term rule has a certain set form. It is a number multiplied by n plus another number. And this common difference of 4 is going to be my first number here in front of my n. So now all I need to do is find the next part of my nth term. And I do that by finding the previous term, or the 0th term. Now if I was adding 4 to go up the sequence, I need to take away 4 to go down it. And that will give me an answer of 3. So my adjustment here, or my extra little bit in my second box, is going to be plussing 3. So my nth term is going to be 4n plus 3. Now we can check this. Remember that n refers to the position of my number, and hopefully if I put the position in, I should get my number in my sequence. So here 19 is my 4th term, so n equals 4. So I'm just going to check that my nth term works for this. Then do 4 times 4 plus 3. 4 times 4 is 16 plus 3 is 19. So I know this works and my nth term is correct. Okay, so now it's asking me to write the 100th term of the sequence. For my 100th term, n is going to equal 100. So to find what the number is for the 100th term, I need to do 4 times 100 plus 3. 4 times 100 is 400, plus 3 is 403. So 403 is going to be my 100th term, which is a lot quicker than working out 100 terms in a sequence. Okay, so finally I'm asked, does the number 205 appear in the sequence? Give reasons for your answers. Sometimes this question is actually very easy to answer. We can spot that in my sequence here they are all odd numbers. If they give you a number like 204 or any other even number, you could just say that it doesn't appear because all the numbers in my sequence are odd numbers. This one is slightly harder because it's given you an odd number and we're not really sure whether it is or not. So the way we're going to do this is we're going to again use our nth term rule. And what we're going to do is we're going to set up an equation. 4n plus 3, which is our nth term, and we're going to see what value of n gives us a value of 205. Now, if this value of n is a whole number, then 205 is in my sequence. If it is not a whole number, then we know that it's not in my sequence. So, I'm going to drop my 2 lines down, take away 3, I get 4n equaling 202. Now I'm going to divide both sides by 4, and if I do that, I get a value of n equaling 50.5. Now, if you remember in my conclusion, if n was a whole number, then it appears in my sequence, then this 205 appears in my sequence. But here, n is not a whole number, so 205 does not appear in my sequence. And the equation here will be sufficient for my reasoning. Okay, so the second example I'm going to go through is where you're given a pattern. Now this is basically exactly the same question as we had just before, only sometimes people get a bit more confused because they don't associate these with numbers. So here's a pattern made from sticks. Hopefully you can spot what the pattern's actually doing. Each time there's another 3 sticks added on the end in this sort of C pattern. Okay, so the first thing that's asking me to do is to draw the next pattern in the sequence. So that's straightforward enough. I just need to copy down pattern 4. And after I've copied down pattern 4, then I just need to put another extra 3 sticks on the end here. Now B is asking me for how many sticks will be needed for the 10th pattern. Now again, just like in my previous example, I could draw out all the patterns up to pattern 10. But instead, there's a quicker way of doing this, and that is using nth term rules. So what I need to do is I need to assign numbers to these patterns. Now what I'm going to do is count the number of sticks there are. So there's 3 in the first pattern, 6 in the next, 9 in the next, 12 in the fourth, and even my 5th pattern here I've got 15. So writing those all out next to each other, I've got 3, 6, 9, 12, 15. To find my nth term out, I need to, if you remember, find the common difference. In this case, it's going up in 3 each time. So I'm going to start my nth term formula as 3n. Now I need to go back a term to the 0th term, taking away 3, and I get 0. So there's no adjustment, it's just going to be 3n. So how many sticks will be needed for my 10th pattern? I just need to substitute n equal to 10 here, and I'd get 3 times 10, which is 30. Okay, so hopefully that's helped you with nth term rules and sequences questions. Have a go at some exam questions, and good luck.